Hey folks, in last episode, we have installed the LTSpice GUI. In this episode, we will do the tour of LTSpice GUI, including several important menu and submenu. We will get used to all the basic toolset of LTSpice GUI required for schematic drawing and simulation using Spice commands. This episode will give you the confidence to draw and simulate any complex design like a pro. So stay tuned, stay focused. Hey guys, welcome back. In today's episode, we will explore the basic GUI of LTSpice. So let me double click and open it. Here you can see the interface of LTSpice is opened as soon as I double click the desktop icon. Now here obviously you can see this one. This is not a part of LTSpice. This is my marker. This I will use to point different things on the screen. So let me focus right now here. This is the basic menu bar, and here you can see only 4 options are there. This is when you do not have any kind of schematics open. So what's inside that? If you click file, you can see that there are new schematic, new symbol, open example, new library, and print. And rest of these are the files that have accessed recently. They will be there. If I click view, you will see toolbar, status bar, and Windows tab. It's very minimal right now. If you go to tools, you can see settings, color preference, and update comp. So update components, basically when you are connected to the internet, it will update the analog component libraries from analog devices website from where we have downloaded the LTSpice. It will link with the server, and then it will download the new components, the new examples. Those are upgraded in the server of LTSpice. And if we go to help, you can see here it is the help, and if you click it, it will open up. Let me show you a HTML help file. So here you can get helps like software installation, modes of operations, right? So all those things you will get. So here is the schematic capture. You can go ahead and take this help, and this will open up in your browser. As you can see here, this window will have the basic menu through which you can navigate to your respective subject, what you want to store in LTSpice. And you can see this is not opening up from the website. So this is opening up from a local directory, and from there it will access the help. So you need not to be connected to the internet to go through and understand help. This is the basic of the LTSpice help that you can get directly from inside the software. So now let me close it and move on to the basic interface here. I have told you that without opening any file of any schematic, right? So this interface remains very minimal. Now, as soon as I open any new file by clicking this button, you can see the menu bar has multiple more components. So now if I go there, you will see the striking difference. Not in the file will have like print preview, print setup, print monochrome, these extra things, save as, close. And if I go to edit, you will see there are a lot of things have come. You can see this is text, this is spice directive. All these things are also available in the toolbar. I'll show you later. However, you can access them from the menu of edit. So here are also things that move, stretch, delete, duplicate. Okay, so these are the editing options, and drawing options is here like line, rectangle, ellipse, arc. So all these are there. Now let us move on to the next menu, which was not there. So hierarchy, I click it. I can see there are 3 options. Open this sheet symbol, create new symbol, and create a new sheet. So these 3 options are coming inside the menu of hierarchy. Now if I move to view, you can see zoom area, zoom back, zoom to fit, and show grid. Show grid is nothing but the things here you can see, right? So I have the pencil right now. So I can mark. So these are the grids you can see. This will help you to draw the circuit, and this will when you draw a line, right? So the line will go snapping through these grids, and that will help for drawing a schematic. Now, couple of more things like mark unconnected pins. So the dangling pins will be marked using this menu, and these are not for our usage. I think this is for the PCB part. And the next point is very important. The next 2 points, the SPICE netlist and the SPICE out. Whenever we are having a schematic right here, we can see the SPICE netlist. By clicking this option, it will show the underlying SPICE netlist that is there, and more options are there like visible traces, auto arrange y-axis. These are regarding the graphs that are coming after the circuit simulation. Here, these 3 were the initial things that when we do not have the new file or new schematic turned on. Next is the simulate. So here we have option run or pause and then stop. This is very similar to any IDE, that is the integrated development environment, like we have talked about GUI in our channel. So there are run and stop, this kind of thing. This is very similar to that. And here there is settings. It was earlier there when the minimalistic view was there. And here is something configure analysis will come into later. However, we will access this menu in a different way, which I will demonstrate while drawing the schematics and turning on the type of an like AC, PC, transient, etc. Next. Now the tool menu is there for multiple options like copy bitmap to clipboard, write image to EMF file. To enhance meta file is a Microsoft Office format where you can use this file for your documentation. That means you have a schematic. If you create a meta file, you can use it in your documentation. In case you are a student, you are writing a thesis, you can use this schematic for your thesis. Later, we have settings, color preferences, update components, and export netlist. So this is for PCB. You can see when I highlight this, right, at the bottom, the status bar is there. It is showing a message, extract a netlist for PCB layout. Now, Windows, we have options with multiple windows, tile horizontally, tile vertically, cascade, close everything, arrange icon. And help, again, we have the same menu we have already discussed. Mostly the help that is used is the LTSpice help, which you can also access from the keyboard shortcut F1. If you directly hit F1, this help will open the local repository of help in your web browser. It could be Internet Explorer, it could be Chrome, it could be Firefox, whichever is there and which you have made default. So this is the basic menus. Now let me have the pencil. Now I will point out the toolbar. So these are new file and open file option. This save file, this is going for settings. This is run and pause, the simulation. This is for multiple zooming levels. Now these are for graphs. I cannot explain right now. I don't have any graphs right now. Here, these 4 are for arranging the windows. These are basic editing options, cut, copy, paste and find, and these are printing options with the physical printers or virtual printers like PDF printers. And now we will mark here that very important part of the toolbar. So this we will be using more frequently. So let me de-highlight or clear the screen, and now I will point one by one. So this is drawing line. So this is drawing ground. That means in every circuit you have to have a ground. This is for adding a pin. This is a resistor. This is a capacitor. This is inductor. This is diode. And this is something else. This is not a logic gate. So this will open up a library of available components, because in circuit design we have numerous components that can be used in a circuit design, and those cannot be fitted inside this entire toolbar. So this button will be very much important to you once start designing. Now we have 2 things. One is move. Move means we can physically move this interface, okay, up and down or right or by just clicking and dragging. Another one is here will help you to select a device. Say suppose you have drawn a resistor, right, like this, and you want to select. So at corner you click here and then drag, it will draw a square and this resistor will be selected. So these operations will be done here. So this is undo and redo options. These are very common to any kind of GUI. And here we can use the rotate or mirror. So this is rotate and this is mirror. Okay, let me clear the highlights. Now next, this is a text annotation. That means in circuit somewhere we have to write some text, which is maybe a description or some important comments that we want to have archived along with the schematic. So this is for use, and this .op will help to insert the spice command. This is very important because in this series we have already talked about different spice commands earlier. The interface here will help you to draw the schematic. That means you will place the components like diodes, like resistors, like capacitors. Okay, it will help to draw. But however, for spice related commands like .inc, .measure, all those things has to be accessed through this particular command. So all those spice things you have to write by hand using this so that they get incorporated along with the schematic. So this schematic editor will help you to ease the node connections. That means this node and this node, say we are connecting here to here. This is very cumbersome in spice if we have huge number of this interface will alleviate. But however, if you are thinking that you will skip the spice command related stuffs by this editor, no, that you cannot do. And you have to do that by using this .op. .op is generally the operating point and it is mentioned at the very beginning. I have already explained in the spice command episode. So those all commands which are very much native to spice, you can insert them using this particular option and it will open up a text box and then you can write the commands by hand. Obviously, you will have some assistance from LTSpice window which you are writing. However, the basic thing, you have to learn the spice language. And this is the reason I have covered the spice language at the very beginning and then I am coming to this particular GUI so that your knowledge is complete. And now when we are diving in the spice design, the schematic design, and then we are plugging in the spice analysis and all the spice commands, you are well ready. Here, let me clear the screen again and we come back to here. Now I will demonstrate the basic components that we use in every circuit. Let me begin with the components. Like this is ground, right? I'll come back to later because I'll be drawing a rough circuit. This is just to demonstrate the usage of the components that you can draw. So let me first write a resistor. You can see as I click the icon, the resistor has come. Now this is vertical. I want to make it horizontal. So what I will do, you can see here it is showing type Ctrl R to rotate or Ctrl E to mirror. So that means mirror means it will flip and create a mirror image, and rotate means it will become horizontal. Now let me come back here again, and if I hit the Ctrl R, another thing I can do here, I can go here and click. As soon as I click, this will rotate and I think this is okay. The same thing we can do with the Ctrl R. So you can see I'm pressing Ctrl R from keyboard and the thing is rotating by its own. So whichever is easier for you, you can use either you can use the Ctrl R from the keyboard or you can do it from the toolbar. So let me place it now. Now it is floating. Once I do the left click, it will place here. It is ready with another resistor. So make it vanish. I'll do a right click and it goes away. Now I will add a capacitor here. So I want it to be in vertical fashion and I click the left mouse button to place it. And again the right mouse button to vanish the next capacitor that has already appeared. Now what I have done, I have left very much less space in the left hand side. I think simple click and drag is moving the canvas. So you can see I have just point out these two are for the component. So for moving the canvas, I just pick at any point or some point and I drag it. So you can see that in the left hand side, I have got a much space. So here I will draw multiple things. Now I will draw one particular inductor and you can see it is in the vertical direction. I want to make it horizontal and from keyboard I hit Ctrl and then R. It has moved, right? But I think the opening or the arrangement is not suitable. So I'll rotate it once more and once more. Now this orientation looks fine for me. So I'll place it here with the left click And with the right click, I'll make this vanish because I do not want any more inductor. Now, there is a component called diode. So let me click the diode and bring the diode. Now I'll use the keyboard shortcut again, the rotate one, right? So it has gone in a reverse direction, right? And now I'll make it rotate again. And again, I rotate it. Now I have my intended orientation. So now I'll click and place it. I need another diode. So I'll not do the right click here. So here, let me place it. But however, I need its direction to be exactly opposite. So I want to mirror it. From keyboard, I will click Control E to mirror it. You can see the diode direction has reversed. That means the current direction will flow in this direction. Here I clicked it and placed it, and I don't need any more diode. So I will right click and make it vanish. Now again, I will click the canvas at some point and drag it because the circuit is progressing more in the leftward direction. Now when there is a circuit, right, definitely we'll need a voltage source. How we can get that? Now we are about to click the component part. And here is a search box. If I type voltage, it will point out to the voltage. Now I will click the voltage. It is highlighted, you can see, and I will use the place. Now we are physically placing this particular voltage here. And we do not need any more voltage sources here. So I'll do the right click and make it disappear. So now all the components are there. Suppose you are a learner, right? So you are drawing a circuit from your textbook. This way you can first place all the component, the voltage sources, and there comes a interconnection part that you can do by this particular thing. So now I have selected this particular wire, right? You can see I can do a left click and then I move forward, and you can see by the crosshair, right? It is actually with the horizontal axis of the diode, inductor and resistance. So let me click here and move up to this point and do again a left click. You can see that this interconnection has been made. You can see that there was a bending. However, that bending did not concluded the wiring. So the wiring started from here, had a bend here, and then moved here up to the diode. So this way you do the internal connection or wiring or interconnection, whatever you say. Now again we are having this cursor. I'll interconnect these two. Again I am emphasizing this is not a real circuit. Just for your understanding of the interfaces, I am connecting them. So now I connect these 2 points. Next I click the resistor point, and then I come at this point, and with the crosshair you can see, let me place the crosshair, and then by this crosshair you can see one line is horizontally aligned and one line is vertically aligned. Now we have the proper grid. That means now you understand the importance of this grid. So basically this crosshair snaps with the grid, and you can now come down and connect these things. So let me come here at this point, click, and then I connect. So all these clicks are single clicks. There is no double click in the wiring. So I will hit the escape button, deselect anything from the keyboard, and I will click and drag the circuit upward so that I have some space for the wiring for the bottom part. Now I'll do the next wiring. Go here, click the wire. Now I here click in capacitance, and I align the crosshair at this point. Make a click to make a bend of this connection. Come here, I connect it. So all these clicks are single clicks, not double clicks. So again I do a click, then come here and I align the crosshair. You can see the crosshair is aligned to the vertical grids. Now here I do a click. From this point I do a single click. And now let me, just to get rid of any tools, I hit the escape. So I have made the circuit connection. Again I am emphasizing this is not a real circuit. I have just made a quick interconnection for a circuit. I don't know how this circuit will perform and what it is called. Now I will place one particular ground connection. So this is the ground. I'll place a ground here. I place the ground and I don't need this, so I right click. Now I will again click the wire, come to this point, I click it, and then I move vertically upwards. My crosshair are well aligned with the line, and I click it so that the interconnection is in. Now I hit escape from the keyboard, and you can see the circuit has been drawn. Now, since this is a virtual tour of drawing a circuit, I will show you every options for this interface. I am not go for analysis, and you have to understand this is not any intended circuit. This is a rough circuit that I am drawing. It has no meaning to me right now. For the sake of using the interface, you can understand how you will connect different components. Here you can see there is a text. So here let me type, this is important comment for the drawn circuit. I click OK, and you can see this is coming. So I place it downwards here. So this will stay. So this is for human reading. Any human is opening this particular file, right? He or she will find this comment, and you want to convey some messages, you can write in this way. Now comes the SPICE directive. For any circuit, right, there will be .op. The .op command will be there. So let me click it and click OK, so that the .op, the operating point, be there. And if I have to add something else like .temp, I give a value like 140 and I click OK. So temperature will come here. So these are basically the SPICE command that are coming by this particular SPICE direct. Now by this way we will feel the needful. Now here I give a .inc and I give some file. Yeah, let me just put it. These are not real, so this will .clip. So it has a clip file. So here, although this will give an error, right, I have just typed to include a spice.lib which will contain the necessary model. So this way I have just demonstrated. Again, don't run this circuit, it will give error. This is for the GUI user. Now let me have some analysis like .tran, right? So when I add .tran, it will add .tran. Now you might be wondering that I have not filled up the rest of the things. In LTSpice, we have a GUI help. Now if I right click on this .tran, automatically the options open up. You can see this is transient, and here you can see the stop time, time to start saving the data, time step, all these things you can fill here, and it will construct the command here. This is a GUI kind of help that you can have, or in case you already have the .tran command in your mind, you can go ahead and write directly in this. Here some more options are there. These can be used from case to case basis. So these we may need, may not need. However, the basic things that we will need are these three: 1, 2, and 3. These three things will be needed in the .tran command. And one more thing, let me clear the screen. Here you can see there is one option, skip initial operating point solution. So this will add a UIC command. This for the replacement of .ic, and this is very much specific for the transient analysis, right? So this is a very local option for the transient to have the UIC. So this is important. I have already discussed this in the SPICE command episodes. So now you can insert AC analysis, DC analysis, noise, DC transfer frequency function, all this by GUI. However, we started with the .tran, so we can fill up with the .tran. And directly, in case you want to access this dialog box, let me cancel and show you how you can have it. So you go to edit, and I think there is an option. Yes, here it is, the configure SPICE analysis. Click here, this one, right? You will have the option, and then you can click OK, and this will come. Or if you just right click, right, and this will come. So I think this is much more easier because you don't have to navigate to the menus and then come. I think, let me cancel it, and once you just right click, this will open up this dialog. This is the easiest way I find, I think, for a schematic designer who is using LTSpice. I think this will be the very easy option to go for. So let me cancel it. We have not saved the file. We may be done with the drawing and all. So let me go to the file and then have the save menu. So this will save just as a draft. You can see getting saved as draft. So this has no meaning. You have to save it in some name. By default, it will get saved in draft. This is a basic problem that you can encounter, and hence I am helping at this point so that you can go to the file and then go to save as. LTSpice, we move to the folder and we name it as rough circuit. This is a rough circuit. We are not doing any kind of proper design here. And now once you have this, you give the name here. You can see automatically the extension has been selected for the schematic. You need not to change this one. So you don't touch this one. You can have the name here and then you will click save. Clear the screen, and in case you want to view what are the options, there's only one option here, and let me save it, rough circuit, and automatically the extension ESC will be added or appended to this name. Now you can see the file has been saved with a proper name here. The rough circuit is coming here. This way you have to save your individual designs with a proper name. Otherwise, it will save as draft 1, draft 2 and draft 3, and later you cannot find them. That's the basic thing you should learn. And we are done here with the basic GUI introduction of LTSpice. What are features there? You can use it. There will be some special part of the GUI when we deal with the waveform, and those will be covered in the following episode. After these episodes, we will have actual circuits which are drawn, and in those episodes, we will cover the additional GUI that may come when you are simulating and viewing the waveform and we are playing with the waveform. So all those things will come. Right now, with this rough circuit, we cannot show them, but this is the basic starting episode that you can have to get familiar with the GUI and how to use the different tool set that is with the LTSpice. We are done here. Thank you very much for watching up to this point, and don't forget to like, share and subscribe. In case you have some dislike, put that as in comments, and bye for today.